Okay, so every spot in a matrix has a sign associated with it. So this sign goes with the number that's already there. And the easiest way to remember is that the top left starts off as a positive. And then it alternates from there. So no matter what the size, the top left is always positive, and then it alternates. So it goes positive, negative, negative, positive, so forth on forever. And then the next row starts off with a negative, then positive, negative, positive, negative. And it just keeps alternating like that for as far as you want to go.
Oh, so this is like opposite always?
Uh-huh.
What is this for you?
So this is to find the determinant. The only time we use this alternating stuff is when we use what's called minors and cofactors. So this is to find the determinant using minors and cofactors. And I'll show an example and then we'll kind of talk about what we did. So the determinant really, what's the best way to describe it? It's one number to describe the matrix, but each matrix isn't unique. Like two different matrices could have the same determinant. So it's not like, oh, this determinant has this number and that number can only go with this determinant. So here's what we do when we're using minors and cofactors. You choose a column, any column, or you choose a row.
Either one, you don't choose one.
Yeah, either one. And you just choose one. So you choose one or the other. I normally choose the one with the smallest numbers, so I choose like 1, 2, and 3, or 2, 1, negative 1. If there's a 0 in the spot, not always, but the 0 is the one I would choose because it's much easier to use. So let's go ahead and let's use this one. So that's this row of signs, right? Because that's the same spot. Does that make sense on that? So what we do is we write down the sign from here. So I'm just going to write those down. Plus, minus, plus. So far, so good. And then I write down the numbers that go in that same order. So 2, 1, negative 1. So those are those three numbers. I should have taught you you learn how to find the determinant of a 2 by 2 real fast too. So this number 2 is in the first row, last column, right? So the only things not in that same row or column are these 4, correct? So we write those next to this. We actually use a straight line for this. The straight line means determinant, not absolute values when it's with matrices. This is going to get messy. Now we have 1, right? Am I going too fast? Because this is new for you guys. So 1's in the middle row, last column. So not with 1 is 1, negative 6, and 3, 2. So I write those down.
Wait, why did you do the 2, negative 4, 3, 2,
so they are not in the same row or column.
Oh, okay.
So not in the same row or column as this one is the 1, negative 6, and the 3, 2.
Okay.
And now we're to the negative 1. So this is the row that negative 1 is with, and this is its column. So I write down 1, negative 6, 2, negative 4. Okay, so I said you're going to learn how to find the determinant of a 2 by 2 real fast. Here's the determinant of a 2 by 2. If I have A, B, C, D.
But did we already learn this?
Yeah, partly, yeah. It's just A, D minus B, C. So it's just those two multiply each other minus those multiplied by each other. So you just multiply this diagonal minus the diagonal coming back the other way. So on each of these 2 by 2 matrices, we're going to find the determinant of each of them. So on this first one, we're going to go 2 times 2 is 4 minus a negative 12. So 4 minus a negative 12 makes positive 16. And we have the 2 in front. So 2 times 16 is 32, I hope. My math's been off today. I messed up on the board. I did negative 6 plus 2 is 8. Yeah. So now on this one, 1 times 2 is 2 minus, coming back the other way, negative 6 times 3. And you can get really big numbers with these. Like you'll get sometimes 700, 300, like, yeah. So minus a minus turns into a plus, but it has a negative 1 in front right here. So we really have negative 1 times 20, which makes negative 20. So we have 32 minus 20. This is why if you have a 0 in here, you use the 0, because what's 0 times anything? So that's why you use ones with 0 if you can, because then you don't have to do anything more with it. Anyways, 1 times negative 4, and negative 6 times 2, negative 12, and negative 4 and negative 12 make, so that's a negative 16, but we have the negative plus a negative 1 in front, which is really just a minus 1. So that makes that a plus 16. So now I just combine these. 32 minus 20 is 12, plus 16 is 28.
Can I just make a picture of this?
Sure. So that's the minors and cofactors, and that's the determinant. So this is the same problem. So if we did it right, we should get the same answer. It's kind of like Goldilocks. I'm going to teach you 3 different ways. One's too hard, one's too soft, one's just right. This one's just right? No. The calculator is the 3rd way I'll teach you. So this one's called duplicating columns. Okay, so we're going to duplicate columns. So what we do is we write the first 2 columns down again. So we just write 1, 2, 3. This only works with a 3 by 3. So the minors and cofactors you can do with a 4 by 4. You keep breaking it down. You make it into like a 3 by 3, and then you take your 3 by 3 and make it a 2 by 2. And so, yeah, but you can do it. The easiest way is just to type in the calculator on all of them, really. But there's comes a time when you do like eigenvalues and eigenvectors, which are a different thing, and you have to know how to do this by hand. So, no, that's a different math class. And it's not horribly bad. It's just if you didn't know how to do this part, then it's like, what are you teaching me, and how does it work? So here we go. We've duplicated these columns, right? All that you're going to do now is you're going to multiply diagonally.
Wait, how did you do the first one?
Oh, so you only do the first 2. Sorry. So only duplicate the first 2. So now we multiply diagonally. And we're going to do it 3 times. This way and then 3 times back the other way. So 1 times negative 4 is negative 4 times negative 1 is positive 4. Now write it down.
Okay.
And then I do the next one. So negative 6 times 1 is negative 6, times 3 is negative 18. And then I do the next one. 2 times 2 is 4, times 2 more is 8. So
Did you just do the middle three?
you do those 3 and that's it, but then you come back the opposite direction and you put those minus. So the ones that come back to like right to left, even on the 2x2 are minus. These ones that come back this way are minus. So I just put a minus and then a parenthesis just so that I remember they're all going to be minus. So now I just start in the corner. Negative 6 times 2 is negative 12 times negative 1. So there's my positive 12. And then 1 times 1 is 1 times 2. So I just could put a plus 2 in there. And then we do the last one. 2 times negative 4 times 3. So negative 24. So now I just combine the ones in the blue and the ones in green.
But it looks negative 4 and 2 is already.
So what happens is this 2 gets used twice right here. And this negative 4 at the end gets used twice right here. So every number gets used twice.
But
Yeah.
those are not okay.
Yeah.
That's just getting important.
Yeah. So negative 18 plus 8 is negative 10. Plus 4 is negative 6. And 12 plus 2 is 14 minus 24. Man, I messed up somewhere in my math on one of these two problems.
Are they supposed to be the same?
Yeah. Yeah. I'm struggling today.
That's okay.
So I'll find the mistake and show you where I messed up somewhere. 14 minus 24 is 10. So really what we have is negative 6 minus a minus 10, which makes 4. Either I wrote the problem down differently than I'd had in here, or I just messed up, which that's more likely.
Are they supposed to be the same?
Yeah. We'll find out which one's right. They're probably both wrong. I'll probably mess up in both places. So we're going to go to the calculator. And I'm going to write those numbers down. I normally make mistakes, but normally not that bad. Unless I taught you wrong on the signs. Okay, so we're going to go second matrix, edit. It's a 3 by 3. So 1, negative 6, 2, 2, negative 4, 1, and then 3, 2, negative 1. Just like with all the other matrices, once we get it typed in, we're going to quit. Well, actually, you can just hit second matrix again. But in the middle of when you hit the matrix menu is the math. If you go to that math menu, the first one's the determinant. So you can go second quit. So did you go second quit?
Yeah.
Then second matrix, math, determinant. Now I go back to my matrix and I choose A and then hit enter. So it's 4. So I messed up on the first one. Hey, here's the mistake. Maddie already found it for me. Negative 4 minus a minus 12. So I put down minus 12, but it's really a minus 12, so it should have been a positive. So that should be 8. And 8 times -1 is -8. So 32 minus 20 is 12, minus 8 makes 4.
Good job, Maddie.
So that's where the mistake was. That makes me feel better about it. That. So this is your homework. Make sure you get it done. And then, as I mentioned before, I'm erasing this because I was going to work it again. But we found the problem back on the previous page where I had done this one, where you multiply 1 times -4 makes -4 minus -12. So minus and minus made that a +12, and 12 minus 4 made 8. So -1 times 8 made -8. And so then when you combine the 32, -20, and -8, then it works out to be 4, and it gives you the same answers we got on the calculator as we did when we duplicated columns. So anyways, that's how that should have worked. So that's how you find the determinant.